do on this worksheet, the bottom right corner says absolute extrema. Okay, you're going to do 45 for 56 on the bottom right. Okay, just finding absolute extrema, it's pretty easy. These are the steps to do it. Okay, there's also, I don't know, maybe like 13 problems in your textbook. That's the e-text. It's posted in the classroom already. Okay, most of it is looking at a graph and just stating things. You don't have to do a lot of work for those. It's nice. I'm going to pick out a random one to do from the worksheet. Let's do number 50. Okay. What did we say our first step was? Find the derivative. Okay, what's the best way to find the derivative of this mother function? Chain rule. I still haven't showed you guys the chain rule video, have I?
No.
Oh, okay, I gotta do that. Alright, so I'm gonna chain rule it. I'm gonna drop down the exponent. I'm gonna reduce it by 1. The inside is gonna stay the same. Times the root of the inside. What's the root of the inside? 2x. Okay. I want to find critical points next. So I want to consider two things. I want this equal to 0. And because I want to solve it equal to 0, I don't want to simplify this. It's factored for me already. I don't want to do anything with it. I also want to just really quickly consider, does f prime not exist anywhere? I don't want to not consider, even though I look at this and I'm like, it's a polynomial. I don't have to think about that. I want to make sure that I do think about it when I need to. What are two situations that we'll see that I might have to consider? If I have any fractions, if I have any rational functions for my derivative, I can't have the denominator to 0. That's where I would have like a blow up or hole or something like that. And then where else do I have to restrict domains? Square roots. Okay, if I can't have negatives under square roots, so that's where my derivative wouldn't exist. Okay, so now I'm just going to set these pieces equal to 0. Can 3 equal 0? No. Where is x squared minus 1 equal to 0? Not just at 1, but plus or minus 1. Where is 2x equal to 0? 0. At x equals 0. Okay. So I found f prime. I identified my critical points. I forgot to write down the endpoints from the problem, but they're on the worksheet. It's from -1 to 2. Okay. So now all I'm going to do is I'm going to take my critical points, so -1, 1, and 0, and I'm plugging them into my original function, and also my endpoints. I have -1 on the list already. The only one I have to add to it is f of 2. Okay, so again, just to reiterate, these are my critical points, these 3. Sometimes you'll see they'll overlap. Okay, and then these 2 are my endpoints. Okay. If you ever come up with a critical point that's not on your interval, so let's say I came up with -2 as one of my critical points, I would dismiss that because it's not on the interval I'm interested in. I would just disregard it. Okay. I'm going to plug all these into my original function. So this one I've got to do -1 squared minus 1 quantity cubed. So I got 1 minus 1 cubed is a 0. F of 1 again into the original. 1 squared minus 1 quantity cubed gets me another 0. F of 0 would be 0 squared minus 1 quantity cubed. -1 cubed is a -1. F of 2 is going to be 2 squared minus 1 quantity cubed. Did I write down this wrong? Oh, I'm sorry. No, I can't multiply right now. Okay, 4 minus 1 is 3. 3 cubed is 27. Okay. So these problems are real. They're the messiest part would be maybe solving the derivative equal to 0. Okay. Which is the biggest? Which is the smallest? 27 is the biggest, right? Which is the smallest? -1. Okay. And then you're just going to write out your answer the way I asked you to. So I will put it up here. Okay, we're going to say that the absolute max is what number? 27. It happens at x equals what number? 2. Okay, and my absolute min is what number? It happens at x equals 0. There's my answer. Okay? And that's all you guys have to do for these. Does that feel okay? All right, it shouldn't be a terrible homework.